Good morning, my Algebra 2 class. I hope that you all are doing well. Today we're going to start off our virtual learning process by learning lesson 5.2, which is polynomials, linear factors, and zeros. So today, while you're at home doing your learning process, there are a few things that you're going to need. You're going to need some paper to take some notes with. You're going to need a pencil in order to write your notes with, a basic calculator to do your basic math operations, and then at the end of the lesson, you're going to be able to begin working on homework 51, lesson 5.2a. This is located in your yellow folder with your weekly papers from all of your classes. To start off, we're going to first learn about how to write a polynomial in factored form. As you can see, we have a polynomial x to the third minus 2x squared minus 15x. The degree of this polynomial is 3. Which means when we write this in factored form, we need to have 3 factors. So when we look at any polynomial and we want to break it down, the first thing we should always look for is a GCF, which is our greatest common factor. When doing that, you're going to first look at your different terms. We have term number 1, we have term number 2, and we have term number 3. In each of these terms, you're going to determine who are your coefficients. The coefficient of our first term is 1. The coefficient of our second term is negative 2. And the coefficient of our third term is negative 15. When we look at each of these individual coefficients, if there is a 1, there is no greatest common factor among your coefficients. The next thing we will examine are the variables. We have 3 variables, all variable x. Each of these x's are raised to different powers, which means they share an x. So it means we have a greatest common factor of x. What we will do with this greatest common factor is we will divide each individual term by x. We will take our first factor, x to the third, and we will divide it by x. We will take our second factor, 2x to the second, and divide it by x. And we will take our final factor, negative 15x, and we will divide it by x. When we divide x to the third by x to the first, we get x to the second. When we divide negative 2x squared by x, we get negative 2x to the first. And on the final term, when we divide x by x, we get x to the 0, which is equal to 1. And 1 times negative 15 keeps us at that negative 15. This now produces one of our factors. And our greatest common factor, x, is our second factor. Like I stated at the beginning, we had a degree of 3, so we need to have 3 factors. We need to take this trinomial and break it down using our X box method. So we're going to create our X box. Remember, at the top of our X box will be our A times C value, and on the bottom, our B value. So our A value is equal to 1, and our C value is equal to negative 15. So we'll do 1 times negative 15, which is negative 15. Then we will take our B value, which is equal to negative 2, and we will put it here on the bottom. B bottom, help you to remember. On the left and right sides of the X box, we look for factors of negative 15. Since A times C is negative 15, that means one of our factors has to be a positive factor, and the other factor has to be a negative factor. So we take our negative 15 and say, what ways can we multiply to get negative 15? We could do 1 times negative 15. We could do negative 1 times 15. We could do 3 times negative 5, or negative 3 times positive 5. These are the only 4 combinations that would create a negative 15. We're looking at these 4 factors below. If we were to combine them by adding them together, which group would create a negative 2? And this is the set that would create it. A positive 3 and a negative 5 multiply to make a negative 15, and they add to make a negative 2. Once we find the two factors for the left side and the right side, we put each of these factors over the a value, which is 1. And then we put our variable of x. Neither one of these two factors on the left side can reduce. So now we have created two factors. This turns into 1x plus 3. And the right side turns into 1x minus 5. Now we have all three factors. We have factor 1, factor 2, and our GCF who makes factor 3. So we'll write out all of our factors. So our final answer is our GCF, x, factor number 1, x plus 3, and factor number 2, x minus 5. This would be your final answer. At this time, we want to give you a little bit of time to practice on your own. We want you to try 3 individual problems. During this extra practice time, what I'll ask you to do is to go ahead after I get done speaking and pause the video. You will pause the video and work out each individual problem. When you feel that you're ready to check your work and ready to move on, you'll hit the play button. Once you hit play, you will see the work being worked out underneath each individual problem, and you can see how you did and made sure that you understand. At this time, go ahead and pause your video. I'll start off by first finding my greatest common factor. And it is x. So I will divide each of my terms by x. And then I'll bring down my greatest common factor out front. I will now Xbox the trinomial. Now I will bring down my greatest common factor, x, and write my two remaining ones, x plus 2 and x plus 5. This will be my final answer for practice time problem number 1. Practice problem number 2. I will first look for my GCF, and that is x. I will divide each of my terms by x. I will then bring down my greatest common factor of x. I will use my Xbox method to find the remaining two factors. And now I'll write my final factor. My greatest common factor, x. My first factor, x plus 3. And my second factor, x minus 7. My final answer. And for practice time number 3, I will look for my greatest common factor. This time, I have a coefficient greatest common factor along with a variable coefficient. So I have 3 and x. So 3x is my greatest common factor. I will divide each term by 3x. I will then bring down my greatest common factor of 3x. I will use my Xbox method to find the remaining two factors. And I will put them over the a value, which this time is 3. I will bring down my greatest common factor of 3x. My factor on the left cannot be broken down any further because negative 1 over 3 does not reduce. So I get 3x minus 1. My factor on the right, however, can reduce because 3 divided by 3 is equal to 1. So I've got 1 over 1x, creating the factor 1x plus 1. Now this is my final answer to the third practice problem. Okay, I hope everyone did really well on your 3 practice problems. I hope if you got something wrong, you were able to see where in the problem that you may have gone wrong. Now, if you're unsure still and have not got a clear understanding or have some questions, please feel free to message me on our Remind app, and I'll be glad to get back with you guys and answer any questions that you have. And remember, later in the week, we will have a live feed video where you'll be able to answer questions at live time. We're going to move on to our next example today, which is find the zeros of a polynomial function. So here we have a polynomial function that has already been broken down into our 3 different factors. We've got factor number 1, factor number 2, and factor number 3. So what we have to do to find the zeros is we take each individual factor, x plus 2, x minus 1, and x minus 3, and we're going to set them equal to 0 since we are trying to find the zeros. Once we set every factor equal to 0, we will then solve each individual equation for x. We'll start with our first one. X plus 2 is equal to 0. We want to get the x by itself, so we have to do the opposite operation of plus 2, which is minus 2. So we'll take and subtract 2 on the left, and we'll subtract 2 on the right. So we have our x plus 2 minus 2 crosses out, they zero out. And then 0 minus 2 is equal to negative 2. This is our first 0. On our second one, we'll take our x. Since we have a minus 1, we will plus 1 on the left, and we will plus 1 on the right. We have our x minus 1 plus 1 crosses out, creating 0. And we have 0 plus 1 is 1. On our final one, we have x minus 3, so then we'll do a plus 3 for the opposite, and equal it to 0 plus 3. Here on the left-hand side, we'll bring down our x, and negative 3 plus 3 goes away, and leaves us with 0 plus 3, which is 3. These are now our 3 zeros. So our answer to our zeros are negative 2, 1, and 3. At this time, I'll have you pause the video lesson as we move on to practice time. We want you to take the same concept that was just taught on the example. If you need to review the example before moving on to the practice, please feel free to pause your video at any time so that you may take time to read through or look over the notes. Again, I'm going to let you go ahead and pause the video. I will work through the problems, and you'll resume and see the work being done when you are prepared. Taking each factor and setting them equal to 0. X equals 0, I cannot go any lower, so I leave this 0 just as is. I got a minus 8, so I plus 8 on the left side and on the right side. So then the minus 8 plus 8 cross out, leaving with x equals 8. On our final factor, we have x plus 5, and then we do minus 5 equals 0 minus 5. Then we have x, the minus 5 go away, leaving me with negative 5. So my 3 zeros, since I had 1, 2, 3 factors, I need 3 zeros. They are 0, 8, and negative 5. And then for practice problem number 2, I will take the first factor, x minus 2, equal it to 0, and x plus 9, and equal it to 0. We have x minus 2 plus 2 equals 0, plus 2, minus 2 plus 2 cross out, leaving us with x equals 2. Then we have x plus 9 minus 9 equals 0 minus 9. Plus 9 minus 9, cross out, leaving me with x is equal to negative 9. I had 1, 2 factors, so 2 zeros, and they are 2 and negative 9. For practice problem number 3, I will set each individual factor equal to 0. We have x minus 3, so we'll plus 3, giving us x is equal to 3. We have x minus 2 plus 2 is equal to 0 plus 2. So x is equal to 2. We have x plus 1 minus 1 is equal to 0 minus 1. So then x is equal to negative 1. We have 1, 2, 3 factors, which means we have 3 zeros. And the 3 zeros are 3, 2, and negative 1. So here's our answer for practice problem number 1, practice problem number 2, and practice problem number 3. Again, I hope you all did very well. I hope you have an understanding of what you are doing as you will move into the homework later on. Again, if you have any questions, please feel free to either text them to me through mine or hold off on your questions as we go into our live session later in the week. Our final example for today's lesson is writing a polynomial function from its zeros. And the question they're asking is, what is a cubic? This is important. Cubic means we're dealing with a degree of 3. This means when I get done, I need to have a degree of 3 for my polynomial. As you can see, we have 1, 2, 3 zeros. 3 zeros, degree of 3. Everything should be lining up pretty good. In our previous lesson, I'll go back, when we had our zeros, 0, 8, and negative 5, and the sample number 1, notice that these guys were resulted from setting each of our original factors equal to 0. So to take what we have been given in our zeros and put them into factors, we change the sign of each factor. So our first factor is -2, so we'll change the sign and make it x plus 2. And that creates our first factor. Since our second factor is a +2, we'll do x minus 2. And that creates our second factor. Since our third zero is a +3, we will do x minus 3, creating our third and final factor. To get to the polynomial, we will have to do some multiplying. You cannot multiply all three at one time. You can only multiply two binomials or two factors at a time. Just like in normal math, you can't multiply 5 times 3 times 7 all at one time, but you could multiply 5 times 3 and then that answer times 7. And we're going to do the same process here. We're going to multiply the first two, x plus 2 times x minus 2, first by using our distributive method, or some people like to say FOIL. We'll multiply the x times x, so distribute x times x is x squared. We'll distribute the x to the last factor. X times -2 is -2x. We will now take the 2 and multiply it times the x by distributing. 2 times x is a +2x. And 2 times -2 is a -4. Once we multiply this way, we will take and combine any like terms. And we will notice that we have two like terms right here smack dab in the middle like a double-stuffed Oreo. We're going to bring down our first term, x squared. We'll combine -2x plus +2x happens to be 0. They go away. And we'll bring down our -4. I will take this answer, I'm going to rewrite it over here, x squared minus 4. And we're going to multiply this answer by our final factor of x minus 3. And we will do the same process. We will multiply x times x squared, which is x to the third. And then x times -4, which is -4x. Then we'll do -3 times x squared, which is -3x squared. And then -3 times -4, which is a +12. From here, we'll combine like terms, if are any, and then we will put it in standard form, which means we start from the highest exponent and working our way down to the constant with no exponents. So our highest degree of exponent is x to the third. Then our next highest degree is a -3x to the second. And then we have a -4x to the first. And then we have our constant of 12. There are no other like terms. This is in standard form. Here is your cubic polynomial function. We're going to give you a chance to practice on 3 problems. Again, just like practice prime during 1 and 2, you will pause the video at this time. When you unpause or unfreeze your screen, you'll be able to see the work shown below. You can pause and start after each problem so to make sure that you're getting an understanding of how each problem works. I will show all the steps for each, and then you come back when you are ready. So my 3 factors will be x minus 5, x minus 6, and x minus 7. I will multiply the first two together, x minus 5 times x minus 6, to get x squared minus 6x minus 5x and plus 30. Because a negative times a negative is a positive. I will combine the two middle terms, x squared minus 11x plus 30, creating my first factors that I needed. So I take this factor, x squared minus 11x plus 30, and multiply it by the last factor of x minus 7. So x minus 7 times x squared minus 11x plus 30. So multiply x times x, giving me x to the third, x times -11x, -11x squared, and x times 30, making me 30x. And then negative 7 times x squared is negative 7x squared. Negative 7 times negative 11x is a positive 77x. And negative 7 times positive 30 is a negative 210. From here, we'll combine all of our like terms. So I have x to the third and no other x to the thirds. We have a negative 11x squared and a negative 7x squared, making us a negative 18x squared. We have a positive 30x plus a positive 77x, giving us a positive 107x. And then we have our minus 210. Here is our cubic polynomial. Right, for example, number 2 for practice time. We got our 3 factors. We got x minus 5. It becomes x plus 5. Then we have another x plus 5. And then finally an x minus 1. We'll multiply the first 2 together. X plus 5 times x plus 5 to give us x squared. And then x times 5 is 5x, and 5 times x is 5x, and 5 times 5 is 25. Now we'll combine the 2 terms in the middle. So I have x squared plus 10x plus 25. I will take this factor and multiply it by our final factor of x minus 1. So we'll do x minus 1 times x squared plus 10x plus 25. We'll multiply x times x squared, making x to the third. X times 10x, making 10x squared. X times 25, making 25x. And then negative 1 times x squared, making negative 1x squared. Negative 1 times 10x, making negative 10x. And negative 1 times 25, making negative 25. We'll bring down our x to the third because there are no other x to the thirds. We'll take our 10x squared, and our negative 1x squared makes a positive 9x squared. Positive 25x minus 10x is the same as a positive 15x. And then we'll bring down the minus 25, creating our cubic polynomial. Now for our final one. We'll take each, so we have x minus 2, changing it to an x plus 2. We have x equals 0, so just x. And then we have x minus 1. So I take my 2 factors, x and x plus 2, rearranging them using that commutative property, which basically means 5 times 3 is the same thing as 3 times 5. So x plus 2 times x is the same thing as x times x plus 2. So we'll distribute x times x is x to the second, and x times 2 is 2x. We'll take this factor and multiply it by our final factor of x minus 1. We'll use our distributive property. X squared times x is x to the third. X squared times negative 1 is negative 1x squared. 2x times x is 2x squared, and 2x times negative 1 is negative 2x. We'll bring down our x to the third, as there are no other x to the third powers. We'll combine our like terms. We have a negative 1x squared and a positive 2x squared, creating a positive 1x squared. And then we only have 1 minus 2x. Therefore, this is our final polynomial function. If you have any questions, please feel free to text me on Remind. And if at this time you'll take out your homework, lesson 5.2a, and begin working on that. You'll notice that in the homework, there'll be examples just like you have seen in the practice time and the examples themselves for you to look at. You may also use your textbook at home to look back at previous examples on examples 1, 2, and 3 to get further explanation if you need more clarification. I hope you guys have a great day. I hope you learned a lot, and I can't wait to talk to you guys tomorrow. Love you guys and have a great night.